All right, so we're going to start working through the next unit. And the first few days here, we're just going to kind of play around with the properties of exponents. Now, this might be new to some of you guys. It might be kind of old hat for others, but uh, this is something that's important to be able to kind of simplify some of these expressions that we're going to start working with. So, just a quick reminder, what are exponents? And what that means is basically just a repeated multiplication. So in other words, x squared is x times x. X to the fifth, there are 5 of them. X to the eighth, we'd have 1x times x times x times x times x. 1, 2, 3, 4, 5. There's 6, there's 7, there's 8. Right? If you have 2 to the third, really that's telling you have 2 times 2 times 2, right? Which will be 8. If you have 10 to the third, 10 times 10 is 100 times another 10 is 1,000, right? So you get big numbers very, very quickly. Some of the properties we want to be very, very familiar with and be able to move pretty fluidly with uh, as we simplify these things. So the zero power, anything to the zeroth power is equal to 1. This is probably one of the easiest properties, and it gets used a lot. Anything to the first power is just what it is. So I'm using the letter A here, but let's say, for example, we had 3 to the 0 power. It seems strange, but that's actually going to be equal to 1. If you had 3 to the first power, that's just 3. Negative exponent. Anytime you have a negative exponent, what that's really telling you is move something from the numerator or denominator to switch places. So a to the negative n will turn into 1 over a to the n. And so the same thing, 1 over a to the negative n turns into a to the n over 1. So let's say we had 3 to the negative second. Well, really, that's like saying 1 over 3 squared. Or if you had 1 over x to the negative fourth, that turns into x to the fourth over 1. All right, so you're going to see some of these happening with variables as well as with numbers. The product power tells you to go ahead and you can just add the exponents. So an example here, if you had 2 to the third times 2 squared. If you think about this for just a minute, there are 3 2's for that one, and then you have 2 2's for that one. That's a grand total of 5 2's. So what we can really do um, is we can uh, we can do 2 to the 3 plus 2 or 2 to the fifth. So that's really the idea behind the product of powers. If you have the quotient, right? So if the product makes you add the exponents, right? And so let me kind of clean this up so we can see it a little bit better. If product makes you add, then quotient is actually going to make you subtract. So m minus n here. So let's say we had x to the fifth over x to the fourth. Now, if we expanded this all the way out, we'd end up with 1, 2, 3, 4, 5 x's over 1, 2, 3, 4. Now, you guys should be comfortable enough to know we can cancel, and what we're left with is 1x in the top, which is x to the first over 1. Well, what this rule tells us is we don't have to do all that work. What we can do is just x to the 5 minus 4. Well, what's 5 minus 4? That's x to the first, right? And so that's a lot quicker than having to do all this canceling. The power to a power rule, this is about the only time that you're allowed to do, quote unquote, distribute. So what that is you get to multiply those numbers together. So if you have x squared to the fourth power, really you end up with x to the eighth, which is 2 times 4. If you have two numbers inside of parentheses like that, what that'll be is a to the n, b to the n. So let's say we had 2 x to the third power. What that would turn into is 2 to the third, x to the third. Well, you take that third and you distribute it to both of those. So this is when you're kind of distributing. And same thing here. You'd end up with a to the n over b to the n. So for us, for our rule here, if you want to see it with an example, so if we had, x over 3 to the fourth power, that would turn into x to the fourth over 3 to the fourth. And then we could figure out actually what 3 to the fourth is. That's a pretty big number. End up being x to the fourth over 81. Right? So The best way to get familiar with all these is just start practicing. So what you want to realize when you fully simplify these expressions, you won't know negative exponents. For whatever reason, somebody a long time ago said negative exponents are terrible ideas. So anytime you start seeing negative exponents, you want to get rid of them. So the 0 power, x to the 0 is just equal to 1. 10 to the 0, 1. Negative 30 to the 0. It doesn't matter. If you don't believe me that 10 to the 0 is 1, plug it into the calculator. In fact, here's what your calculator would tell you. You have 10. We're going to raise it to the 0 power. It equals 1. You look at the next example, negative 30 to the 0. So, oh, excuse me. We go negative 30. We're going to raise that to the 0 power. It's 1. It's kind of a strange property, but it's very, very helpful at times as well. All right. So first power is probably even easier. You just literally write what's there. 15 to the first is 15. X, Y, Z to the first will just be X, Y, oh, Z. And you're done. Negative exponents, remember this just means that we're going to switch if it would be in the numerator. So a way to make this a fraction, put x to the negative third over 1. So what that'll turn into, 1 over x to the third. Put this as a fraction. So this will turn into 1 over a to the fifth. And here, since y squared is in the denominator, you're just going to switch it. Y squared over 1, or a lot of people would just write that as y squared. Turn the page. We'll start putting some of these together. Product powers, x to the third times x squared. This is really the same thing as just x to the 3 plus 2, which is x to the fifth. Here, add all these together. The one kind of trick here is to understand there's a 1 there. So we have x to the 5 plus 2 plus 1. 5 plus 2 is 7 plus 1, so we end up with x to the 8th. There are 8 x's. If you want to do this the long way, 1, 2, 3, 4, 5 x's here, 2 x's here, 1x here, for a grand total of x to the 8th. But knowing these rules, you can get through stuff a lot quicker. Here we have x to the 12th times, or a to the 12th, a to the 0. So in other words, a to the 12 plus 0, which is just a to the 12th. Or if you look at this, you could have also said that's equal to 1. So you have a to the 12th multiplied by 1. Anything multiplied by 1 is still just a to the 12th. The quotient powers tells that we can go 8 minus 2, which would be b to the 6th. Again, the long way with this would be to write out 8 b's. 1, 2, 3, 4, 5, 6, 7, 8 over 2 of those. And you just cancel until there's none left, and that leaves us with 1, 2, 3, 4, 5, 6 b's. So that would be b to the 6th. This route right here, although it's effective and you can get it right, there's a lot more room for error. My hope is that you guys are really starting to learn these properties. So here we do 3 minus 4. Be very careful because now we have y to the minus 1. Now remember, if you go to the previous page, the rule is no negative exponents. Well, now all of a sudden we've got a negative exponent. So pretend like this is a fraction. Y to the negative first over 1. Well, that turned into 1 over y to the first. Here we have x to the 7th. And remember, that's a 1. Minus 1 would turn into x to the 6th. All right, so there's the quotient power. Power to power, we're really just allowed to just multiply those. That's x to the 10th. This would be 6 times 3, which is 18. 6 times 0 will be 0. Remember, this is a chance to use that 0 power. Anything to the 0 power is just equal to 1. So sometimes you end up using multiple properties at once. The power of product rule will tell us to go ahead and distribute that 4 in here. So that'd be x to the 4th, y to the 4th. Here, take that 5 in there. So we have a squared. So 5 times 2 is 10. 3 times 2 is 15. Or 3 times 5 is 15. Here, distribute these in. So we'd end up with 3 squared times x squared. Now 3 squared is a number you should know. 3 squared is 9. So let's go ahead, get rid of the exponent, clean it up a little bit. 9x squared looks better than 3 squared x squared. Power of a quotient rule. So this is just distribute that third power all throughout. So we have x to the third on the top, and then since you have a third in the bottom, you end up with y to the 9th in the denominator. Here, quote unquote distribute. So what's 2 times 6? Well, that's 12. And then 4 times 6 is 24. And we're done. Don't try to simplify any further. You can't simplify the 12 and the 24 since the 12 stuck with A and the 24 stuck with B as exponents, right? This is not the same as 12A over 24B, right? This tells us these are two different things altogether. So don't try to confuse them. I don't know if me actually saying that makes it worse, but that's as far as we can go with 23. 24, go ahead and distribute that in. So we have 5 squared over z, 7 times 2 is 14. And 5 squared is a number we should know, so we can do 25 over z to the 14th. So as you turn the page here, go ahead and give these a shot, and the next video within the bulletin will be me kind of walking through all these problems. But take a few moments, try these on your own, simplify them as far as you can, and then come back and watch that next video.